Greetings and welcome to this week's edition of the Mr. Science Show. My name is Mark West and I'm coming to you from an orange Sydney. Sydney recently experienced one of the worst dust storms that it's ever had, and it was a completely eerie experience. This week's podcast is an enhanced podcast which includes a number of photos from various users of the service Flickr of the Sydney dust storm. All the photos that are in this podcast come from Flickr and are available to use under Creative Commons licenses. If you'd like to see links to the original photos and the users who upload them, get over to my website at www.mrscienceshow.com. We should certainly thank people for making their photos publicly available. Waking last week in Sydney was a very eerie experience. Blood red light peeked through the sides of my blinds, and given I was half asleep at the time, I thought the 4 horsemen of the apocalypse had come to Earth. When I shook the haziness from my head and peeked outside, the view was astonishing. Not surprisingly, Twitter was going nuts with comments and on-the-fly photos, and the TV and radio news broadcasts were full of dust storm stories. Dust storms are not uncommon in Australia. Indeed, Central and Eastern Australia are a major global source of atmospheric dust. And this particular storm, estimated to be about 600 kilometres long and dumping 75,000 tonnes of dust into the Tasman Sea every hour, could be headed to the ski slopes of New Zealand. That'll teach them to beat us at rugby. Dust can travel a very long way in the atmosphere, with dust from Chinese storms found in the French Alps. This particular storm had its origins in the Indian and Southern Oceans, where low-pressure storms create severe cold fronts. Low-pressure air sinks to the ground, forcing hotter, higher-pressure air upwards. This can cause thunderstorms, and on Monday, winds of more than 100 km per hour formed in South Australia. As inland Australia is in drought, the winds picked up dust not fixed to the ground by vegetation. The dust likely came from the Lake Eyre Basin, according to ABC Science Online, and has caused the worst pollution ever seen in New South Wales. The reddish colour of the sky is an interesting phenomenon. Normally during the day the sky is blue. This is because of Rayleigh scattering. Shorter wavelength light from the sun, which is blue, is scattered by the air in all directions to a greater degree than longer wavelength light, red. The amount of scattering is related to the 4th power of the wavelength. Blue light, with a wavelength of about 400 nanometers, is scattered about 10 times more efficiently than red light, with a wavelength of around 700 nanometers. The scattering in this case is mainly due to oxygen and nitrogen molecules smaller than the wavelength of the light. Due to the scattering of blue, when you look directly at the sun, you see more of the longer wavelength light, which is why it appears yellow. The rest of the sky is lit by the diffuse scattered blue light. At dawn and dusk, the sun's light has to travel through more of the atmosphere to get to your eyes as it comes in at a tangent to the Earth. Go on, I dare you to draw it. This means even more blue is scattered and a larger piece of the sky looks an even deeper red. Dust particles are quite large compared with oxygen and nitrogen, and so do not scatter light in the same way. Some dust absorbs light more effectively at blue wavelengths than at red wavelengths, meaning that light shone through it will appear more red. That is, the dust itself has a red colour. Dust also scatters sunlight, but as the particles are large, this scattering is independent of wavelength. This means that the dust particles act something like tiny mirrors, diffusing the light throughout the sky. As the light that hit the dust was already red due to Rayleigh scattering, it was then scattered throughout the whole sky. Normally at sunrise, the red colour is confined to only a small part of the sky. The presence of dust, and pollution for that matter, can cause beautiful effects. As the sun climbed higher in the sky, the red colour softened. Eventually, the sky just looked a dirty orange, which is the colour of the iron-rich dirt. If you'd like any more info on the physics of light scattering, get over to my website at www.mrscienceshow.com. And also remember to get over there to check out the original photos that we've used in this enhanced podcast. My name's Mark West. Thanks very much for joining me. I'll see you next time on the Mr. Science Show.